Alright, so I want to describe to you how you go about the process, or how to go about the process of finding the sample size necessary to estimate the mean. It's very similar to what we use to estimate the proportion. We're going to have a formula, and because we're looking for a sample size, or sometimes they use the wording how many, we're going to be looking for an n formula, because n to us is the sample size, or how many that they talk to. We're not going to choose a formula with p's and q's in it because we want to estimate the mean, not the proportion. So if the question says, hey, what's the sample size necessary to estimate the proportion, we're going to use the only formula with p's and q's. When it says to estimate the mean, we're going to use this formula, and it goes back to z alpha over 2. And the reason why it's going to go back to z alpha over 2 is because that's a bigger number than the t alpha over 2's. So it's going to be a z alpha over 2 sigma over e, and then a big squared on the outside. That's how you'll see that formula. It's actually on page 323, formula 7.4 is where they first describe it, and you'll watch them use it in examples. If you've read through the book, you'll also see them describe it in PowerPoint presentations as well, but this is to be supplementary to that. And so what's happening in this problem is there's only a few things that you need to know. There's only 3 unknowns in there. One of them is z alpha over 2, and you're going to get that really nicely because that's corresponding to like the 99% confidence, right? Or maybe it's 90%, or maybe it's not even one of the standard ones. Maybe it's 92%. Any one of those, if we have that confidence, we can get our z alpha over 2 by what we were doing in the previous section. The error is going to be a stated error. It's going to be given in the problem. They're going to tell us how close they want to be. And so just like with the one for the proportions, we're going to have to figure out what sigma is, right? In the previous ones, you had to figure out what p hat and q hat is. And so there's going to be 2 situations that can come up for sigma. Either it's going to be given by a prior study, or they're going to tell us to estimate it with. So it's going to be given somehow. And if it's not given, then what we have to do, so if it's not given, let me write that. What we're always going to do is use what they call the range rule of thumb. We haven't had to use it yet, but the range divided by 4 is a quick and dirty kind of estimate for the standard deviation. It's usually too big, and that's why they're okay with us using it. So the range, if you remember, is high minus low. And this divide by 4. The divide by 4 just comes from experience. It comes from separating the data into quarters. And it's usually a larger estimate than what sigma really is. And so it works well in this setting. So if I model this formula, they could ask a question like this. Find how many students to randomly select in order for their mean age to be within 2 years of the actual mean for all students. So I don't know if this is the greatest examples, but you'll see other ones. Be 95% confident, and the range of student ages is from 16 to 86. So if they don't give us a standard deviation to go off of, they'll typically give us a range of acceptable values. And so as we look at this problem on its own, the first thing that we want to do is realize what they're asking us to do. They're asking us to find how many. So how many would be n. How many to select in order to estimate their mean. So there I'm going to use the formula that doesn't involve p's and q's because that's for proportion. Now I'm going to use this one. They're going to say, hey, I want to be 95% confident. So we already know that this is 1.96 by our experience in the last section, or it's in the bottom right hand portion of that chart if you don't have that memorized yet. The error involved they gave us, the error involved, let me go in here and highlight it in green, is 2. So we're going to come here and put a 2 down here, right, in that same green color. And so the one last thing that we need is this sigma, right? We know to square in the end, sigma. Well, they didn't, if I read through this problem, they never gave me a prior study, but what they did give me is a range of values. So we're going to estimate sigma. So I'll put the wavy equal sign. That means it's approximately equal to. And I take the high minus the low and divide by 4. And if I take the 86 minus the 16 and divide by 4, I get 17.5. So 17.5 is going to be my estimation for the standard deviation. And that's it. Now we're just going to run the numbers. So our n is equal to the 1.96 times the 17.5 divided by 2, the whole thing squared. So I take my 1.96, multiply by 17.5, and divide by 2 and hit equals, and then you just square that result. And squaring that result, I get 294.1225. And again, this is the pure benchmark, so we're always going to round up. So we're going to report the answer of 295. So that's just a general way to solve for these if you're given a range of values. The other thing that could happen is they could say, hey, assume that sigma is equal to 17.5, or the last time we ran a study it was 17.5. And you can just grab that 17.5 number as the standard deviation. So hopefully that makes sense in conjunction with the other things you're reading and studying. But I'll do an example problem right after this as well that's straight from the textbook.